Hi, this is the class 4 analysis of electrical circuits, and today we are going to explain how to reduce the circuit and how to calculate voltage, intensity and power in each one of the components. For this circuit I have a source voltage of 20 volts and I have 6 resistors. The value for this one are 5 to 8 kilo ohms. Then the first thing is to reduce. We are going to reduce this one. That is it is a serial circuit. And we need to just to sum both values. In this case 4 and 8 kilo ohms, and the new value is 12 kilo ohms. Now we need to solve this one. This is a parallel circuit and the value for R4 is 15 kilo ohms, and it is going to be the next circuit. This is going to be R7, it is going to be R8, and it is going to be 15 kilos minus 1 plus 12. In this case, I am using the reciprocating value for this one and the reciprocating value for the resistor. The new value is 6.666 kilo ohms. Now the next circuit for this one is to solve this one, that it is a serial circuit, and the value for R3 is 8 kilo ohms. The new circuit gives us a new resistor. And we need just to add both values. R9 is 14.666 kilo ohms. Now we need to reduce this one. This is a parallel with R9 and R2. It is of 10 kilo ohms. The new value is R10 with the values of 5.94 kilo ohms, and this one is R1 with a value of 5 kilo ohm. Then the last reduction for this circuit is a serial circuit where we just need to add both values, and the last resistor RT is going to be 10.94 5 kilo ohms. Now, When we finish this one, we have the simplified circuit. We need to start to get voltage and intensity for each component, going back until the first circuit. Then we are going to use the Ohm law. For this, we are going to use voltage, intensity for resistor, and intensity is equal to voltage over resistor. Then this circuit has an intensity, and this resistor, according this, has the same 2 points nodes of the voltage source. And then for this one, we have that there is a 20 volt voltage, and then we need the intensity. The intensity for this circuit, total intensity is equal to voltage over resistor. And the value is we are going to use a complete number. This is 20 over ohms. And we can the value is this one, and we need to convert to another value. If I move the point, this is ampere, this is going to be 0.913 milliampere, or if I move 6 spaces, it is going to be 913 microampere. Micro is 10 with exponent minus 6. Now this is the current for all the circuit. Now I'm going to move this current to this circuit because this is the flow. Here it is going to be the same current. It means that for those resistors we have the same current. Then now we can calculate the voltage here. That is voltage on resistor 1 is equal, according to Ohm law, to intensity and multiply for 5 kilo ohms. The value voltage is 4.5 volts. And then we can calculate the other value just changing okay, let's stop. Ok, pensamos de nuevo esta parte y continuamos aquí. And then the intensity for this for the simplified circuit is 20 over 10,945 ohms. It is equal to this is ampere. Then if we move the point, okay, this is the value. If I move the point 3 spaces, it is going to be 1.827 ampere, milliampere. This movement is for milli. Now, this current is the same for the last circuit because it's the same circuit. It's following the same trail. Then we can calculate then, according this, the voltage in this resistor, that it is R1. According Ohm's law is intensity, and we multiply using the resistor, and the value is 9 volts. Here we have this voltage, and then the voltage on R10 is equal to this one, the same current, and we use the value for this resistor, in this case is this one. If we add these two, it is going to be this voltage, because